everyone and welcome back to Study Room. In today's lecture, we'll be discussing a topic of mensuration, that is surface area of a cube, cuboid and cylinder. So let's get started. The very first thing that I'll be teaching you is the total surface area of a cube, cuboid and cylinder. So the basic concept behind this is that the total surface area of any solid is actually the sum of the surface areas of each of its faces. For example, if we have a cube in total has 6 faces, we'll calculate the area of each of these faces and then add them up. So that will result us in the total surface area of the cube. So in short, we can say that the surface area of any solid is nothing but the sum of the areas of its faces. Now let us find the total surface area of a cuboid. Now we know that a cuboid is made up of 6 rectangular faces. So, we have to calculate the area of each of these rectangular faces, add them up and then we'll get the area of the total surface area of the cuboid. So, let us try finding it out. So, if we open the cuboid, it will result in a structure like this, which has been given over here. That is, we'll have 6 total regions, that is the 6 faces. Region 1 represents the first face, similarly 2, 3, 4 and 5 and 6 represents the other faces of the cuboid, which is rectangular. So let's find out the area of each of these regions, 1, 2, 3, 4, 5, 6, add them up and that will result us in the total surface area of the cuboid. So the area of region 1 is actually height multiplied with length. The area of region 2 is breadth multiplied with length. The area of region 3 is breadth multiplied with height. The area of region 4 is length multiplied with height. The area of region 5 is breadth multiplied with height. And the area of region 6 is length multiplied with breadth. So we can see that there are 3 pairs of identical faces. So what happens is that we have in total 3 combinations. That is length breadth, breadth height, length height. And each of these combinations occurs twice. So we can say that we have 2 times length into breadth, 2 times breadth into height and 2 times length into height. So what we'll do is we will take out 2 common outside. So we'll be left behind with length into breadth plus breadth into height plus length into height within the bracket, and that is what the area of a cuboid is. It is the total surface area of a cuboid whose length is L, breadth is B and height is H. So from our previous calculation of the area of each of the 6 faces of a cuboid, we concluded that the total surface area of a cuboid is 2 times length breadth plus breadth height plus length height, where L represents length, B represents the breadth of the cuboid and H represents the height of a cuboid. Now that we have learned calculating the total surface area of a cuboid, let us calculate the total surface area of the following cuboids. So the first cuboid that has been given to us over here is this one. In this cuboid, we can find that the length is 6 centimeters. So I'll be writing length is equal to 6 centimeters. The breadth over here is 4 centimeters. And the height given to us is 2 centimeters. Now we know that the formula for calculating the area, the total surface area of the cuboid is 2 times length breadth plus breadth height plus length height. So we will put the value of L, B and H in this formula to get the total surface area of this given cuboid. So what we have to do is the total surface area will be equal to 2 times length multiplied with breadth, that is 6 multiplied with 4 plus breadth multiplied with height, this is 4 multiplied with 2 plus length multiplied with height, that is 6 multiplied with 2. So this gives us 2 times 6 into 4 is 24 plus 4 into 2 is 8 plus 6 into 2 is 12, which is equal to 2 multiplied with 44 and ultimately gives us 88 centimeters square as the total surface area of this given cuboid. Now we have another cuboid and in a similar way we will be calculating the total surface area of this cuboid as well. So in this cuboid the dimensions given to us are length is equal to 4 centimeters, breadth is again equal to 4 centimeters and height given to us is 10 centimeters. So I'm writing over here, the total surface area of this cuboid 2 will be equal to 2 times length multiplied with breadth, that is 4 multiplied with 4 plus breadth multiplied with height, that is 4 multiplied with 10 plus length multiplied with height, that is again 4 multiplied with 10. So this gives us 2 multiplied with 4 into 4 gives us 16. 4 times 10 gives us 40 and again 4 times 10 gives us 40. Adding all of them up, we get 16 plus 40 plus 40, that gives us 96. So we have 2 multiplied with 96. That ultimately gives us 192 centimeter square as the total surface area of this cuboid 2. Now I'll be teaching you the lateral surface area of a cuboid. So first, let me tell you what is a lateral surface area. Lateral surface area is actually the surface area of the 4 walls of a cuboid. Now, you'll be confused that what do you mean by 4 walls? So by 4 walls, I mean that lateral surface area is the area of the cuboid excluding the top face and the bottom face. If we exclude the area of the top and the bottom from the total surface area of the cuboid, then we'll be getting the lateral surface area of the cuboid. So in any question where we have been told to calculate the lateral surface area or we have been told to calculate the area of the 4 walls, so that means that we have to calculate the area of the faces, all the 4 faces of the cuboid, but we have to exclude the area of the base and the top portion. So ultimately the formula for the lateral surface area of the cuboid will be equal to 2 times length plus breadth multiplied with height, because the area of the top portion and the area of the bottom portion has been included. Only the lateral faces, that is the 4 faces, has been included. Now that I told you that the lateral surface area of the cuboid is the total surface of the area of the cuboid minus the area of the base and the top. So in the reverse way, we can say that the total surface area of the cuboid is equal to the lateral surface area of the cuboid adding plus 2 times the area of the bases. That means the area of each base will be multiplied with 2 and then adding it up with the area of the 4 walls, that is lateral surface area, will result us in the total surface area of the cuboid. So this is an important relationship between the lateral surface area and the total surface area of a cuboid. That is, the total surface area of a cuboid will be equal to the lateral surface area of a cuboid plus 2 times the area of its base. Now, we have to observe the changes in the total surface area of a cuboid, or we can say basically the lateral surface area of the cuboid, when we are interchanging the length and the height. So in this first case, this is a cuboid that has been given to us and we have to calculate the lateral surface area. So here the lateral surface area will be the area of these 4 side faces, excluding the top and the bottom. So it will be 2 times length height plus 2 times breadth height. We'll take 2 times height common and we'll be left behind with length plus breadth. So ultimately the lateral surface area of this cuboid will be 2 times length plus breadth into height. Now let us see that if we change the length and the height, like interchanging both of them, does it make any changes or it remains the same? So when we do so in this cuboid, the lateral surface area will be 2 times length height plus 2 times length breadth, because this is actually the area of each of the rectangular faces, that is the area of the side walls excluding the top face and the bottom face. So from here we'll be taking 2 times length common and we'll be left with breadth plus height. So here the lateral surface area will be 2 times breadth plus height multiplied with length. So we find that if we interchange the length with the height in a cuboid, then its lateral surface area will also be changed, because the total surface area, when we calculate, we include the top and the base. But when we are interchanging it and calculating the lateral surface area, then the top and the base also gets interchanged and the entire lateral surface area gets interchanged. Moving on to the next topic, that is the total surface area of a cube. Now we all know that cube is made up of 6 square faces that are identical to each other. So if we calculate the area of any one face of a cube and then multiply it with 6, that will give us the total surface area of a cube. So the area of a single face of a cube, if each of the edges L, will be side into side, that is L multiplied with L, that is L square. So now we have in total 6 faces. So 6 multiplied with the area of each face, that is 6 multiplied with L square, will give us the total surface area of a cube. Or we can even calculate individually. What we can do is, we can mark region 1, 2, 3, 4, 5, 6 for each of the 6 faces of the cube. Calculate each of the area of the faces, that will be L square, L square, L square, and we'll get 6 times of L square, which results in the total surface area of a cube. So the total surface area of a cube is 6 times L square, where L is the length of each of the edge of the cube. And talking about the lateral surface area, in case of lateral surface area, we have to remove the top and the bottom portion. That means the area of the top and the bottom needs to be excluded from the total surface area. So the lateral surface area of a cube will be 4 times L square. And the lateral surface area is also known as the area of the 4 walls. Now that I've taught you to calculate the surface area of cube and the lateral surface area of the cube, let us try doing some problems. So in cube 1, where each of the edge is 10 centimeters, we have to calculate the total surface area. So the formula for total surface area of the cube was 6 times L square, where L was the length of each of the side of the cube. So over here we'll have 6 times the length of each of the side of the cube of this cube A is 10 centimeters. So I'll be multiplying 10 into 10. So this gives us 600 centimeter cube as the total surface area of this cube A. Now coming to the next problem, that is cube B. In this cube B, we have to calculate the lateral surface area. The formula for lateral surface area was 4 times L square, where L is the length of each of the edge of the cube. So we have 4 multiplied with the length of each of the edge of the cube is 8. So we have 8 multiplied with 8. So this gives us 4 multiplied with 8 times 8 gives us 64. So here ultimately we have 256 centimeter square as the lateral surface area of this cube B. Now we have an interesting problem. Let us take 2 cubes. Each cube will have side B centimeters, or let's say B units. So B unit is the side of this cube and this cube as well. Now let us join both the cubes. The resulting figure will be a cuboid. So this cuboid is the resulting shape after joining these 2 cubes. We have to calculate the total surface area of this cuboid, and let's see that whether the total surface area is 12B square or not. So in order to calculate the total surface area of the cuboid, the formula is 2 times length breadth plus breadth height plus length height. So that is equal to 2 times the length over here will be equal to B plus B, that is equal to 2 times of B. So the length will be 2 times B. The breadth is B, so 2 times 2B multiplied with B plus breadth height. Breadth is B and the height is also B. So I wrote B multiplied with B plus length height. Length is 2B and height is B. So ultimately we get 2 multiplied with 2B square plus B square plus 2B square. 2B square plus B square plus 2B square gives us 5B square, which when multiplied with 2 gives us 10 times of B square. So 10B square is actually the total surface area of this resulting cuboid. It is not 12B square as mentioned over here. It will always be 10B square. Now, the second problem that we have over here is that, what if instead of 2 cubes, we are taking 3 cubes each of side B. And we'll join all the 3 cubes to form a cuboid. And then calculate the total surface area of this cuboid. In order to calculate the total surface area of a cuboid, the formula will again be the same, that is 2 times length breadth plus breadth height plus length height. But over here, the length of this cuboid will be equal to B plus B plus B, that is equal to 3 times B. The breadth will also be B and the height will also be B. So I'll put these values in the formula of the total surface area of the cuboid. So it's 2 times 3b, that is the length, multiplied with b, that is breadth. Plus we have breadth into height, again it will be b multiplied with b, plus length into height, that is 3b multiplied with b. So this gives us 3b square plus b square plus 3b square. Adding all of them up, we get 3 plus 3, 6 plus 1, 7b square. So we have 2 multiplied with 7b square, that ultimately gives us 14b square. So the question that was asked over here was that in the first case, is the total surface area 12b square? The answer will be no. The total surface area is not 12b square. Instead of that, the total surface area is 10b square. And in the second case, the question asked was that is the total surface area, which is of the cuboid, formed by joining 3 cubes, is 18b square? So again, the answer will be no, that the total surface area is not 18b square, rather it is 14b square. The next question that we have with us is, how will you arrange 12 cubes of equal length in order to form a cuboid of the smallest surface area? So this is an interesting question. We have been given 12 cubes. We have to arrange it in such a way so that the cuboid so formed will be of the least surface area. The surface area has to be minimum. It should occupy, like the surface area has to be minimum. So in order to do so, what we can do is, we will take at first 3 cubes. Place the 3 cubes adjacent to each other in a line. And then we'll take 3 more cubes and place it on top of these 3 cubes. So we have a setup of 6 cubes. And then we'll prepare a similar setup of 6 cubes by placing 3 cubes adjacent to each other and 3 cubes on top of them. So ultimately, we'll join these two setups. 6 plus 6 will give us 12 cubes in total, and this particular cuboid that has been formed will be occupying the least surface. The surface area will be minimized in this possible setup. So it will look like the figure that I have drawn over here, somewhat like this. 3 cubes in one line and then 3 cubes on top of that cube. Again, join a similar setup adjacent to it. So in this case, what happens is that the resulting cuboid will take up length is equal to 3b, because b, if I'm taking b as the length of each edge of the cube, so it will be b plus b plus b. So the length of this resulting cuboid will be 3 times b. The breadth of the cuboid will be b plus b, that is 2 times b, and the height of this resulting cuboid will be 2 times b again. Now, we know that the formula for calculating the total surface area of a cuboid is 2 times length breadth plus breadth height plus of length height. Let us put the values of length, breadth and height in this formula and see what's the total surface area of the resulting cuboid. So we have 2 times, the length over here is 3 times of b, breadth is 2 times b. Again we have breadth height, that is 2 times b multiplied with 2 times b, plus length height, that is 3 times b multiplied with height is 2 times of b. So we get over here 2 multiplied with 3 into 2 gives us 6, b multiplied with b gives us b square, plus 2 multiplied with 2 gives us 4, and then b multiplied with b gives us b square. 3b multiplied with 2b will give us 6 times of b square. So ultimately what we have with us is 6b square plus 4b square, that is 10b square, plus 6b square, that is 16b square. So 16b square when multiplied with 2 is 32b square, and it will be in square units because it is the total surface area. Area is always in square units. So from here we can conclude that 32b square is the least area that this setup of 12 cubes can occupy when it is formed into a cuboid. So the least surface area of the resulting cuboid, which is made out of 12 cubes, is 32b square, and the setup should be made in such a way that we have 3 adjacent cubes and then 3 more adjacent cubes on top of that, and then aligning a similar setup with the previous one. Now I'll be teaching you the total surface area and the lateral surface area in a cylinder. So what happens in a cylinder? We have a curved face and then we have 2 circular faces, one at the top and one at the bottom. So the lateral surface area of the cylinder is nothing but the surface area of this curved face. Now let us cut this cylinder and open this lateral surface area. That means that this curved portion is cut from middle and it is opened. When it is opened, it will be forming a rectangle whose length will be equal to the circumference of a circle, that is 2 pi r, and the breadth of this rectangle will be equal to the height of the cylinder. So, the area of this particular rectangle will be equal to the area of this curved surface of the cylinder, because this rectangle has been made from the curved surface area of the given cylinder. So, the curved surface area of the given cylinder will be equal to the rectangle's area, that will be length multiplied with breadth. So, this will be equal to, the length is 2 pi r and the breadth is h. So, 2 pi r h gives us the curved surface area, or we can say the lateral surface area of the cylinder. Now, when we add the area of the two circular bases, that is the circular base at the top and the bottom, with the lateral surface area, then that gives us the total surface area of the cylinder. So, in order to calculate the total surface area, first I'll be writing the lateral surface area or the curved surface area, that is 2 pi rh, and then add up the area of those circular bases. One is at the top, other is at the bottom. We know that the area of the circle is pi r square. So, we have two circular faces. So, the area of two circular faces will be pi r square plus pi r square, and adding up this with the lateral surface area of the cylinder, that is 2 pi rh. So, we'll be getting pi r square gives us 2 pi r square and 2 pi rh, which is the lateral surface area. So, we'll add both of them up in order to get the total surface area of the cylinder. From these two terms, we have to take 2 pi r common. So, when we take 2 pi r common, we'll be leaving behind r plus h. So, we have 2 pi capital R and r plus h within bracket as the total surface area of a cylinder whose radius is r and height is h. Now that I have taught you the formula for the total surface area of a cylinder, that is 2 pi r within brackets r plus h, let us solve the total surface area of the given cylinders. So, over here, the first cylinder that has been given to us has a radius of 14 centimeters and a height of 8 centimeters. We have to calculate the total surface area. So, we will put the value of r equals 14 and h equals 8 in this formula of total surface area. So, we get 2 multiplied with the value of pi is 22 by 7. Radius given is 14 centimeters. Again, we have r plus h. R is 14 and h is 8 centimeters. So, the 7 gets cancelled out with 14, leaving behind 2. So, we ultimately have 2 multiplied with 22 multiplied with 2 multiplied with 14 plus 8 again gives us 22. When we multiply all of them, we get 1936, that is 1936 centimeters square as the total surface area of this given cylinder 1. Now we have another cylinder 2. But in this case, we have not been provided with the direct radius, but we have been provided with the diameter. This entire portion is the diameter, which is equal to 2 meter. So, if the diameter is 2 meter, we know that the radius is equal to half of the diameter. So, the radius will be equal to 1 meters. Now, we have to calculate the total surface area. So, we'll be using the same formula, that is 2 pi r plus h. So, over here we have 2 pi, the value of r, that is the radius, is 1 meters. So, I'll be writing multiplied with 1. And again the radius is 1. Adding up with height. Height given over here is 2 meters. So, I'll add 2 over here. So, we ultimately get 2 pi multiplied with 2 plus 1 gives us 3, which results in 3 multiplied with 2, that is 6 pi. Now, over here, let us put the value of pi as 3.14 instead of 22 by 7. So, we'll have 6 multiplied with 3.14, which ultimately gives us 18.84 meters square as the total surface area of this cylinder 2. Now, I taught you the formula of lateral surface area of the cylinder. Lateral surface area of the cylinder was equal to 2 pi r h. This 2 pi r is actually the circumference of the base of the cylinder and h is the height of the cylinder. So we can say the lateral surface of area of a cylinder is the circumference of the base of the cylinder multiplied with height. Now let us see if this case is same in the case of cuboid also. So in the case of cuboid, the lateral surface area is given by 2 times length plus breadth into height. Now just observe this part. 2 times length plus breadth is actually the perimeter of a rectangle. It is the perimeter of a rectangle. So we can say that the lateral surface area of a cuboid is equal to the perimeter of the base multiplied with the height. So the question that has been asked that can we write the lateral surface area of a cuboid as perimeter of a base multiplied by height? So the answer will be yes, we can write the lateral surface area of a cuboid as the perimeter of the base multiplied with height, because 2 times length plus breadth is the perimeter of the base, because in a cuboid the base is a rectangle and the perimeter of a rectangle is 2 times length plus breadth. Now we have been given with another question, that is, an aquarium is in the form of a cuboid whose external measurements are 80 centimeters, 30 centimeters and 40 centimeters. So let us take length as 80, breadth as 30 and height as 40 centimeters. Now the base, side faces and back face has to be covered with colored paper. We have to calculate the area of the colored paper required. So we have to actually cover the base, side face and the back face with colored paper. So we have to leave behind the top face and the front face uncovered. So what we have to do is we have to first calculate the area, the entire total surface area of the cuboid, and then subtract it with the area of the top face and the area of the front face, because on the top face and the front face we don't need to apply the paper. We have to only apply it on the side faces, on the base and on the back face. So what we'll do is we'll calculate the total area and then subtract the area of the top and the area of the front face in order to calculate the total area of paper required. So here first we'll calculate the total surface area of this cuboid. The total surface area of this cuboid will be equal to 2 times length into breadth plus breadth height plus length height. So we have length as 80. So 80 into 30 plus breadth height, that is 30 into 40, plus length height, that is 80 multiplied with 40. So from here we get 2 times 80 into 30 gives us 2400. 30 into 40 will give us 1200. 80 into 40 will give us 3200. So ultimately we have over here is 2 multiplied with, when we add these three things up, we get 6800. So we have 6800 multiplied with 2, which gives us 13,600 centimeter square as the total surface area of the cuboid. Now we have to calculate the area of paper needed. So the area of paper needed will be equal to the total surface area of the cuboid minus the area of the top portion and the area of the front portion. So we have to write the total surface area of the cuboid, that is 13600, minus area of top and minus the area of the front portion. So in total we have 13600. The area of the top portion will be equal to 30 multiplied by 80, because 30 is the length and 30 is the breadth and 80 is the length. So when we multiply length into breadth, we'll get the area of the top portion. So the area of the top portion will be 80 multiplied with 30. And in order to calculate the area of this front portion, we have to multiply the length with the height. So we have 80 multiplied with 40. So here we get 13600 minus 80 into 30 gives us 2400 minus 80 into 40 gives us 3200. We'll add these two quantities up first. So we have 13600 minus 5600, which ultimately gives us 8000 centimeters square. So we can conclude from over here that 8000 centimeters square is the total area of paper that is required to cover the side faces, the base and the back face of this cuboidal aquarium. Let us try solving another application-based question. So we have a cuboidal room whose internal dimensions are given as 12 meter, 8 meter and 4 meters. So this will be the length, this 8 meter is the breadth and 4 meter is the height of the room. We have to find the total cost of whitewashing all the 4 walls of the room if the cost of whitewashing is rupees 5 per meter square. So the first thing we have to calculate is the area of 4 walls. In order to do so, we know that the area of 4 wall is nothing but the lateral surface area of a cuboid. And the formula for the lateral surface area of cuboid is 2 times length plus breadth multiplied with height. So we'll have 2 times length over here is 12 meters and breadth is 8 meters. So we'll have 12 plus 8 multiplied with the height that is 4 meters. So we have 2 multiplied with 12 plus 8 gives us 20 multiplied with 4, which ultimately gives us 160 meters square. So this is the area of the 4 wall that needs to be whitewashed. Now the information that has been provided to us is that 1 meter square area, if we have to whitewash this 1 meter square area, then the cost that it will incur is rupees 5. So for whitewashing all the 4 walls, the area that needs to be whitewashed is 160 meters square. So 160 meters square area needs to be whitewashed. So the cost that will be incurred will be 160 multiplied with 5, which gives us rupees 800. So this is the cost of whitewashing the 4 walls of the room. Next up, we have the second part of the question, that is, what will be the cost of whitewashing if the ceiling of the room is also whitewashed? So what we have to do is to calculate the area of the ceiling as well, then calculate the cost of whitewashing the ceiling and add it up with the cost of whitewashing the 4 walls. So that will result in the total cost. So first we have to calculate the area of the ceiling. So area of ceiling will be equal to length multiplied with breadth. It will be equal to length multiplied with breadth because ceiling is ultimately rectangular in shape and it is length multiplied with breadth. So we have 12 multiplied with 8, which gives us 96 meters square. Now again we'll use the information that was given to us that 1 meter square area requires rupees 5 to be washed for whitewashing. So we have over here that 1 meter square area requires rupees 5. So in order to whitewash 96 meter square area, the total cost incurred will be 96 multiplied with 5, which gives us rupees 480. So the final answer that the total cost of whitewashing the 4 walls along with the ceiling will be equal to the total cost of whitewashing the 4 walls plus the total cost of whitewashing the ceiling. That is 800 plus of 480 rupees, which gives us rupees 1280. So this is the total cost of whitewashing the 4 walls along with the ceiling. The next question that we have with us is based on cylinder. So there is a building and in that building we have 24 cylindrical pillars. The radius of each of the pillar is given as 28 centimeters. So I'll write first the information that has been given. That is radius is equal to 28 centimeters. Now the height of the pillars is 4 meters. So height is equal to 4 meters. Now just because the height is given in meters and the radius in centimeters, so I'll be converting the radius in meter as well. So this will be 0.28 meters. Now we have to find the total cost of painting the curved surface area of all the pillars when the rate per meter square is rupees 8. Using this information, we have to calculate the total cost. So at first, we have to calculate the curved surface area of all these 24 pillars. For that, let us first calculate the curved surface area for one pillar. So the curved surface area of one pillar. So pillar is cylindrical in shape. So the curved surface area of one pillar will be the curved surface area of a cylinder, that is 2 pi RH. So this will be equal to 2 multiplied by 22 by 7. R is 0.28 and height given to us is 4. And this curved surface area will be in meters square. So the 7 will get cancelled up with 0.24 and give us 0.04. We'll multiply 2 with 22 with 0.04 and 4, and thus we'll be getting 7.04 meters square as the curved surface area of one pillar. Now we have to calculate the curved surface area of 24 pillars. So the curved surface area of 24 pillars will be equal to 24 multiplied by the curved surface area of one pillar. So 24 multiplied by 7.04, which gives us 168.96 meters square. So this 168.96 meters square is the total area that needs to be painted. Now the information that has been provided to us is that 1 meter square area. That means for 1 meter square area, the cost of painting is rupees 8. We'll be using unitary method. So we have to paint the total area of 168.96 meters square. In order to paint this 168.96 meters square area, the cost incurred will be 168.96 meters square. The cost incurred will be 8 multiplied with 168.96 rupees. Because if the cost of painting 1 meter square area is 8 rupees, so the cost of painting 168.96 meter square area will be 8 multiplied by 168.96 rupees. So this will give us rupees 135.1.68. So it's 1351.68 rupees. This is the total cost of painting all the 24 pillars if the cost per meter square is rupees 4. Now let us try solving another question related to cylinder. So the question given to us over here is find the height of the cylinder whose radius is 7 centimeters and the total surface area is 968 centimeters square. So let us consider the height to be h. So let's say that the height is h centimeters. Now we know that the formula for total surface area of a cylinder is equal to 2 pi r plus h. Now we know that the radius of the given cylinder is 7 centimeters, so we'll put 7 centimeters in place of r. So this will be 2 pi 7 and then 7 plus h. So this is actually the total surface area. But in the question, we have been provided that the total surface area is 968. So this quantity, that is 2 pi into 7 within bracket 7 plus h, will be ultimately equal to this given total surface area. So we'll write according to the problem, 2 pi 7 plus h will be equal to 968. So from over here we have 2 multiplied with pi multiplied with 7. So we have 2 into 22 by 7 multiplied with 7 and then 7 plus h equals 968. This 7 will get cancelled off and then we are left with 7 plus h. And we'll take this 2 multiplied with 22, that is 44, towards the right hand side. So we have 968 divided by 44. Because this 44, that is 2 into 22, was multiplied on the left hand side. So when we take it to the right hand side, it will go in the denominator portion. This gives us 22. So we have h is equal to 22 minus of 7. So ultimately we get h is equal to 15 centimeters. So we can say that the height of the cylinder, whose radius is 7 centimeters and total surface area is 968 centimeters square, is 15 centimeters.